Electrolysis is electrical current flowing through liquid, which causes chemical changes. Yes, you did hear that correctly. Current flowing through a liquid. Now, not all liquids can conduct. The liquid can be a molten ionic compound or an aqueous solution. In either case, it must be able to carry current. Let's take a common example, for example, table salt. If you heat sodium chloride to over 801 degrees Celsius, it will melt. The liquid will contain free-flowing positive sodium ions and negative chloride ions. This simply means that sodium and chloride ions will be able to move freely within the liquid sodium chloride. Positive ions are called cations, negative ions are called anions. Now consider putting two electrical conductors into the liquid. Copper would be good as it has a higher melting point. Nothing happens to the ions at this point, but if we connect the two bits of copper to an electrical cell or a power supply, the things would start to get interesting. We do need to sidestep for a moment to look at the electrical current in metal from our lesson Behavior of Metallic Structures that I will post tomorrow. We know that electrons in a metal aren't bound to particular atoms. They form a sea of electrons that can move easily. If a potential difference or a voltage is applied across it, this could form electrical cell or a battery. The electrons will begin to drift towards the positive terminal of the battery. Current is the state movement of the charge. In this case, electrons. Now, let's go back to our molten sodium chloride. We've added our copper wires, let's call them electrodes, and now we'll connect these to an electric cell. And this will cause one electrode to become positively charged and the other negatively charged. This has an immediate knock-on effect in the molten sodium chloride, which you'll remember is a mixture of sodium cations, and chloride anions. Anything positively charged in the liquid, in this case positive sodium ions, is going to be attracted towards the negative electrode, and anything negatively charged is going to be attracted towards the positive electrode. This is because opposite electrical charges attract. When the ions meet the electrodes, electron change happens, and this triggers a chemical reaction. Solids can form, gases can be given off, and new solutions can be left behind. It all depends on the liquid and what material the electrodes are made from. There is more detail about this in a lesson interpreting electrode equations. There are special names for the electrodes, which are usually metal plates with a larger surface area than a piece of wire. The positive electrode is called anode, it attracts anions, and the negative electrode is called the cathode. It attracts cations. The liquid is effectively conducting the electrical current. The only difference is that the charge carries in the liquid. In other words, the charged particles are moving are ions. If liquid has free moving ions and conduct like this, it is called an electrolyte. Remember that electrolysis can also take place in an ionic solutions as well as molten compounds. The more concentrated the solution, the greater the ion flow rate. Ion flow rate can also be increased by increasing the potential difference or voltage across the cell. We will be studying several examples of electrolysis in more detail in other lessons, so stay tuned for that. For the time being though, here is a summary of the key ideas about electrolysis. Electrolysis is the flow of electrical current in a conducting solution or a molten liquid that causes chemical changes. The conducting liquid is called an electrolyte and has free moving ions. The conducting plates, bars, or wires inserted into an electrolyte are called electrodes. Positive ions are called cations and are attracted to the cathode. Negative ions are called anions and are attracted to the anode. When the current flows in an electrolyte, it is the ions that move and carry the electrical charge. When the current flows in the electrodes and the wires, it is the electrons that move and carry the electrical charge. Thank you and have a nice day.